Dear students, greetings to all. In the last video we have discussed some questions. So I expected some of the answers from few of the student, but unfortunately there is no answers. Anyhow, today I am going to reveal the answers. Just listen carefully. The first question is that find out the more stable carbocation. So find out the more stable carbocation. Option here there are two cations, A and B. Okay. So in these two cations, you can observe that here the positive charge is present on the secondary carbocation, and here also the positive charge is present on the secondary carbon. Okay. So now what is going to affect here? The lone pair of electrons present on the oxygen, which is going to affect the carbocation. Because here if you observe what will happen, this lone pair of electrons will shift to this carbon. When the lone pair of electrons shift to the carbon, adjacent carbon, automatically the carbon deficiency will be overcome. Okay, so here in the B you don't have that type of facility, because though lone pair of electrons are moving adjacent, but the positive charge is present on the next carbon, so it is not possible to get the stabilization by this mesomeric effect. So that structure A is the more stable carbocation compared to the B. So structure A is the stable carbocation. Okay. Now second one, arrange the decreasing order of stability in the following carbocations. Here there are three carbocations are there. The first carbocation is the benzyl carbocation, second one is the cyclopropenyl cation, and third one is cyclopentadienyl cation. So here what is the factor which is going to affect the stability of carbocation, that we can see here. Do you know that there is aromatic character in the structure 1, structure 2? Any molecule which shows the aromatic character when it obeys the Hockel rule. Hockel rule is nothing but it should have that planar structure, and all the carbon atoms should be sp2 hybridization, and there should be alternative double bonds, and most importantly it should follow that 4n plus 2 pi electron rule. So here n equal to 0, 1, 2, 3. Okay. So this is the benzyl carbocation. So benzyl carbocation is aromatic in nature. How it is aromatic means there are 7 carbon atoms are there. In these 7 carbon atoms, alternative double bonds, planar structure is possible, and also all the carbon atoms are sp2 hybridization. Okay, so it gives that finally CH2 this is the cation, this is called tropylium cation. So this gets the stabilization by aromatic nature. And cyclopropenyl cation, this is also aromatic because of all the carbon atoms are sp2 hybridization, and it follows that 4n plus 2 pi electron rule, and there is a planar structure. So but compared to first one, the stability will be decreases in the second one, because of there is only one pi bond is there, and the first one there are 3 pi bonds, and resonance structures will be more resonance structures, more stability. And cyclopentadienyl cation is the unstable compared to 1 and 2. So you can give the decreasing order, means first one is greater stability than second is greater stability than third. Okay. Next one, which is most stable carbocation in the following? So there are many factors to affect the carbocation stability. One is the resonance effect, another one is the mesomeric effect, hyperconjugation, inductive effect. So in all those things, first resonance is most influenced factor to make it stable. So that here you can see that triphenyl methyl carbocation is more stable, and then second one, tricyclopropyl methyl carbocation, then trimethyl methyl carbocation. So here the third is the most stable carbocation because as it has that 9 resonance structures. Okay, so third is most stable, then second, then first. Okay, most stable carbocation is the third one. Okay, next one you can see that find stable carbocation. A is vinyl carbocation, B is methyl carbocation. Vinyl carbocation, we know that carbocation, if it is attached to electron donating group, that makes the carbocation stable, and if it is attached to the electron withdrawing group, that makes carbocation unstable. We know that this is a sp2 hybridized, and this is electron withdrawing group, and which makes carbocation destabilization compared to methyl carbocation. So find a stable cation means option B is the correct answer. So this is the correct answer, and stable carbocation is methyl carbocation. Okay, I hope you understood. If you understand, please follow, share, subscribe for more videos. Then I can make it more videos. Thank you.